Good morning, everybody. Thank you so much for joining us this morning. Welcome to the Fueling Collaboration discussion series. We're really excited to have you all today for what's going to be a very, very engaging panel. My name is Andrea Brandon. Just kidding. My name is Amanda Mahaffey, and I'm a Deputy Director at the Forest Stewards Guild, and I'm filling in for Andrea, who is a Science Delivery Specialist with the Northern Research Station. It is my privilege to serve as the host for today's discussion. Before we get started, we have a short poll to set up. Eric, if you're able to launch the poll, we just want to know a little bit about you, and we'll leave it open for about 30 seconds. Our 3 questions will help us understand where you're joining from, your position type, and how you heard about this series. So we'll give folks a chance to answer this quick poll as you are zooming in and getting comfortable and getting all settled. By the way, while the poll is being completed, I'll just remind folks that Fueling Collaboration is inspired by the many fun discussions that we've had around multiple fires and campfires and on the fire line, and sometimes sitting and enjoying a fizzy beverage after a long day at a conference. So the goal today is that you'll get to hear from our panelists as they have a really, really engaging conversation about phenology. And you get to eavesdrop and ask some questions, but we've got a really great panel coming up. So we're going to close this poll in 5, 4, 3, 2, 1, and sharing the results. All right. So thank you for completing that quick poll. The majority of you are consider yourself to be a land or natural resource manager. We have a good range of fire practitioners, researchers, and others, and a few people that are students. That we're all students of life, but thank you for being here, and some folks in extension. Wow, the Lake States and Midwest are really representing today, closely followed by the Northeast and the Southern states. We also appreciate having folks from the Central Apps and the Southern Apps and from tribal lands, as well as from some other parts of the US and internationally. Thank you for being here. Many of you heard about today's webinar from Fire Science Exchange newsletter, and there's assorted other communications. So let's stop sharing that. And again, thank you so much for completing that poll and giving us a sense of where you are all coming from. So, let's let some folks in from the waiting room because we had a lot of people register for today's session. So just before we begin, before I turn it over to our panelists, Fueling Collaboration is a panel discussion series presented by the Joint Fire Science Program's Fire Science Exchange Networks in the Eastern US, as well as the USDA Forest Service's Northern and Southern research stations. This is our 4th season offering Fueling Collaboration. If you've joined us before, welcome back. And if it's your first time, we hope that you find today's event equally informative and fun. Our goals are to bring together researchers and land managers to learn about and discuss the latest in fire science and application, and to build a collective learning and collaborative opportunities across the region. Prior Fueling Collaboration topics have covered a range of themes, including fire history and its application in forest management today, fire seasonality and expanding the burn window, smoke management, prescribed burning in the WUI in the East, all using a similar format to what you'll see today: group discussion, minimal PowerPoints, and built on questions submitted when you registered for today. If you like today's discussion, I welcome you to view the recordings of our past panel discussions. Lindsay will pop a link into the chat in just a moment where you can find all those past recordings. Before we get into today's topic, I have a few logistical items to address. First, today's webinar is being recorded and will be made available on both the Fueling Collaboration and Northern Research Station websites. Closed captioning is available. Please click on the CC button at the bottom of your screen for captioning. Lastly, this panel discussion has been approved for 1.5 Category 1 CFEs by the Society of American Foresters. We are using the participant list to submit to SAF. So if you are seeking credits, please make sure your first and last names are listed correctly on the participant list. If not, you can change your name by clicking on the ... next to your name and selecting rename. So today's discussion is focused on the phenology of fire, seasonality of fire, opening the burn window. All of these elements focus on making up a fire, what goes into a fire regime: frequency, intensity, severity, extent, scale, and seasonality. Our panelists are going to bring fresh voices to how we can learn from listening to our fire-dependent plants and animals and let the fire effects lead us towards desired outcomes. Before I turn it over, I want to mention the slide sorry, our organizers. It's really a deep team, and I happen to be covering for Andrea today, but we have a variety of folks from the Northern and Southern research stations and from all of the Eastern Fire Science exchanges that are part of your team, serving you today and bring you together. So a huge thank you to everybody on the team. Once again, we have a few more people in the waiting room. If we can let them in, they can catch up to where we are. Let's see. I also want to mention we have one more discussion a month from today, February 15th, on successfully bridging the gap, Eastern U.S. models of fire science and management collaboration. So if you haven't yet, be sure to register for that panel. We will draw inspiration from successful case studies in the Eastern United States, where land managers and scientists have forged pioneering partnerships, yielding tangible advancements in the field. Let's see. So I think with that, I will introduce Dr. Todd Aschenbach, who is a professor of natural resource management at Grand Valley State University in West Michigan, and he'll be serving as the moderator for today's discussion. Todd will introduce our panelists in just a few minutes. So I'm going to stop sharing my screen, and we'll give Todd a chance to share his screen, and we will get going. So thank you so much, and we'll get rocking and rolling in just a moment. Let's see. So I think Jack might be working on the screen share.
I can do the screen share, but it looks like Todd dropped off again.
Oh boy. This will be fun and interesting. Todd's been having some technical difficulties, as always happens with these panels. Jack, would you be willing to begin introducing our panelists by name while we're waiting for Todd to zoom back in?
Certainly.
All right, I appreciate it. And
sure,
Todd will join us soon. Thank you.
And feel free, folks, to add or introduce yourself more, since I wasn't prepared to do this. But yeah, Todd Aschenbach, hopefully he'll jump back on and he can continue this. And then we have Mary Parr. She works at Pierce Cedar Creek Institute. She's a stewardship manager there. She's also working as a grad student at Grand Valley State University, working on Phenology of Fire, or Season of Fire for plants. Tyler Briggs works at Albany Pine Bush Preserve. He's the resource manager. I think you've been there since 2010, 2011, as the main burden boss, correct? And so yeah. Okay. And then Don Hagan works. Don, why don't you introduce yourself? It'll be easier. I'm juggling. There's text coming in from Todd, so I'm gonna try to get him back on too.
All right. Well, hey, everybody. I'm Don Hagan. I am an associate professor of forest ecology at Clemson University here in South Carolina.
Awesome. And you want to pass it to Matt?
Yeah, I'll pass it to Matt Vaughn.
Hello, everyone. Yes, my name is Matt, and I am Director of Stewardship and Forestry Education with Forest Stewards.
Awesome. Thank you. Apologize for the delay. We're trying to get everybody in. Let's, I think if we can, let's, okay, Jack is working on getting Todd back in. But for now, if Lindsay, if you're able to spotlight all of our speakers that we have, we will get Todd back in momentarily. So we'll give him a moment. I think maybe what we could do is potentially start with our quick round of introductions, where you get to share a little bit more about yourselves. And then when Todd gets back on, he had just a few slides that share some fundamentals of phenology that might help all of our participants get set. So let's see. So maybe we'll go around. And I think that the question was, when you first burned, according to the local phenology, what did you find exciting, surprising, or revealing? So would anyone like to start us off with kind of your self-introduction question?
I can go first, Amanda.
Thanks, Don.
Yeah, so I mentioned that I'm in South Carolina, but I'm originally from Florida, and my earliest, burn experience was in Florida back in the early 2000s. And, coming from Florida or getting that experience in Florida, there was already this sort of established culture of burning in different seasons. And there was some science to support that. And so then coming to South Carolina, I'm working with a lot of land managers here, mainly in the Southern Appalachian region. And they're mostly burning in the dormant season. They had a desire to expand their burning programs to include some growing season burns, but there just wasn't the science out there to support that yet. So for me as a researcher, that was very exciting to be able to do some sort of fundamental science and some of the first fire seasonality work in the Southern Appalachian region. And another thing that's really exciting is just it's been really neat to see how eager those land managers have been to take that science and actually apply it.
Very cool. Thank you. Matthew, can we turn to you next?
Sure, yeah, thanks. Yeah, I find seasonality to be a really exciting frame to look at fire and thinking of. I had my first burn in the winter in the middle of March, so that was fairly typical in the Southern Appalachian region. But I've just been really excited to see more growing season burns and just expanding, just burning later and later into the year. And I've seen that progression in my years in the region.
Awesome. Thank you. Mary, do you mind if we turn to you next?
Yeah. So working as a land manager, I manage a lot of tall grass prairie and also oak woodlots. And so we started integrating some of the growing season burns into our fire regime probably about 3 years ago. And so I kind of have the perspective of a land manager, but then also coming in as a graduate student and kind of looking at different locations throughout the Southern Great Lakes Basin and how those sites are also affected by it. So yeah, it's been very interesting just to see the observational items and to see like how forbs are kind of flowering within the same year and looking at warm season grasses and looking at these different functional groups and kind of how they're responding. So yeah, it's been exciting to kind of see with both of those lenses how the systems are recovering through time. And then also, like being the land manager, I'm also kind of in charge of the fire program. So I kind of get a lot of autonomy with what different burn regimes I'd like to use. So yeah, it's been kind of fun coordinating a lot of those different burns as well.
That's awesome. Thank you so much. And we'll pass it to Tyler, speaking of land management.
Hey, good morning, everybody. So yeah, like Jack mentioned a minute ago, I'm the fire manager at the Albany Pine Bush Preserve, and the Pine Bush is a giant glacial deposit of sand in the capital region in New York. So it exists between the cities of Albany and Schenectady, and it's a 3,400 acre preserve that's mosaic, not contiguous, of inland pitch pine scrub oak barrens that supports 20% of New York's species of greatest conservation need, including the federally endangered Karner blue butterfly. So I started with the commission in 2011, and they had already started growing season burns when I got here. So I inherited a program that had already been burning in the dormant and growing season. The program started in 1991, and then they started just burning in the dormant season then, and then in the early 2000s they started doing growing season burns. So it was something that was already going on when I got here. I got my burn boss certification in 2016, and I've bossed 99. I went back and looked for this talk, 99 burns to this date from 16 to 23. And almost 1/3 of those burns were in the growing season, the months of June, July, August, and September. And you get different results burning in different seasons. My boss is always encouraging me to burn as much as we can here. We're trying to burn 10% of the preserve in any given year. And so anyway, anytime you can get fire on the ground is good.
Awesome. Thank you for that. Just a quick update. So Todd is with us on the phone. We all love Zoom, don't we?
Hello, everyone.
Hey, thanks for joining us, Todd. So I think
Yeah.
I think to get us started, so Jack, I think, can share his screen to show those introductory phenology slides, and we'll hope to get your
Correct.
video back shortly, but this will help kick us off. Thanks all for the intros, and great, Jack is able to share his screen, and here we go. So Todd, via Jack.
Yeah.
Thank you.
So thanks, everybody. I'm sorry for the technical difficulties on behalf of cyberspace or what have you. Of course, Murphy's Law. I've been on hundreds of Zoom calls before, none bigger than this one, and of course things crash. So that's just how it goes. So my name is Todd Aschenbach. I'm a professor here at Grand Valley State University. I teach fire courses. I do research on prescribed fire plant community restoration. So that's kind of a brief background on me. So what I kind of want to get us rolling with, I'm glad we got the panelists to do their introductions. So Jack's sharing the screen, and the second slide that we're looking at here, it indicates what phenology basically is, and it's just a timing of reoccurring biological events, right? So plants grow, they senesce, birds migrate, retirees go to Florida in winter. Things happen year round, right? And so if we look at this this particular slide, we see that in the winter, the resources are basically below ground, right? Not a lot of above ground movement there. And then as we progress through spring and the growing season, those resources, those sugars and whatnot, they pop back up into the above ground shoots, makes flowering happen and seeding and fruiting and that sort of thing. So that's the spring and growing season. And then we get to fall where, those resources then go back down, primarily back into the root system. So, deciduous trees lose their leaves, et cetera, et cetera. And so basically phenology of plants in this case is looking at where the resources are. Now, one of the issues is that a lot of our burning traditionally has been applied during the dormant season only, right? So looking at this chart, you can see my fire there basically. But the reality is fire occurred even in Michigan almost year round, aside from a couple of months perhaps. I mean, I've burned in early December and late February. So, they can be somewhat off years, but the bottom line is we have effectively artificially restricted our burn window to, a couple months in, late winter, early spring for the most part. So Jack, if you want to move on to the next slide, please. And so when we talk about the phenology of fire or a phenological approach, it really recognizes that different species have different phenologies. They're doing different things at different times of the year. So if we apply fire at a particular time, it will have either positive or negative effects on a particular species or group of species, depending on when you apply that fire. And so we can see in this chart, for instance, or this graphic, I'm not going to go through all of these, but you can see warm season grasses, for instance. If we were to burn in April or May, well, for warm season grasses, those resources are underground, so those grasses aren't vulnerable to fire. And so there tends to be a positive effect, in part because you're releasing nutrients back into the soil, you're reducing some of those warm season grass competitors. Now, if we fast forward and burn in June through August, for instance, that's when those resources are above ground. That's when those warm season grasses are going to be much more vulnerable and have a negative effect. So again, we can kind of look at this chart. I don't want to go through it too much, but the big picture here is we can burn at different times of the season. Another term you might have heard related to this is pyrodiversity, right? So, diversity of a disturbance. And Jack, if you want to go to the next slide, please. So, of course, in this panel discussion, fire certainly impacts the soil, air, water, But the things that we're going to focus primarily on are the plants and animals. And that's because even though fire affects air and water and soil, as managers, terrestrial managers, right? We don't typically manage those things. The soil is largely what you get, and we typically focus on plants and animals. And if we're being kind of honest, we oftentimes focus on the plant community if we're trying to affect a population of animals. And so, not surprisingly, our topics are impacts of this phenological approach to plants, also impacts to wildlife. And then because we're part of the natural world, that means we're also part of the fire world as well. And so our other three topics are the professional, social, and cultural considerations of this approach to fire, implementing phenology and fire management. In other words, how do we do this? And then lastly, we'll finish it off with the fifth topic of what's next. What are some of those gaps that we have in our knowledge, or things that we would like to learn, basically. And so, these topics are derived from the participants' questions. Of course, we can't incorporate all of the submitted questions, so we're kind of trying to do our best job here. And we should have a little bit of time at the end for additional questions. And so with that, I'd like to kind of move on to the topics at hand, if you will. And the first thing that we're going to talk about is the impacts to plants. And so I would ask, Mary or Don, and of course the other panelists that want to chime in, ultimately, what do the plants tell you about why, when, and how to burn your area, and then also some positive or negative effects that you've experienced when you burn at different times of the year.
And while you're getting ready to answer, I'll just mention again for everybody, we're working on our technical difficulties. We hope to have Todd visually up soon, so you don't just hear this voice from above. But thanks everybody for your patience as we have little technical difficulties through this. Back to the panelists.
Do you want to go first, Mary, or would you like me to?
Yeah, I can take a crack at it. I think that one of the most important things of kind of deciding when and how to burn is having a really good knowledge of what you have, a good knowledge of the current plant composition in your site, whether it's more old field or if it's remnant, if you do have rare or threatened species, and then just knowing their biology and when they're kind of in bloom, when they're very productive throughout the year. That will kind of help you gauge when is a good time to burn, or vice versa if you're trying to suppress something, knowing their biology of when are they going to be in flower or also producing, and then having a good idea of your ecological goals. So knowing, if you're targeting shrubs or woody plants, knowing what times of year are going to be best for suppressing those. Similar with invasive species. If you're working with very specific species, kind of cue in on their biology and when they can be suppressed.
Yeah, and I agree with everything Mary just said. I'm coming to you from the Southern Appalachians. You can see my picture in the background. That's the Blue Ridge Escarpment. And the Blue Ridge Escarpment is an extremely rainy place. It's very wet. We get, upwards of, 90 inches of rain in some places along the escarpment. So it comes to us as a surprise to many people, I think, that this landscape is flammable at all. However, if you look at just where we're located, we get a lot of rain. We also have a very warm climate, right? And so it's a very productive ecosystem, and these plants just produce a lot of fuels, and this landscape is flammable any time of the year that those fuels are dry enough to ignite. And so those timeframes are not restricted to the dormant season. There's a lot of evidence on this wet landscape that fire is an important process, and there's a lot that we're still learning. So I think some of the strongest evidence is the presence of these fire adapted or fire dependent species. One of which that comes to mind is Table Mountain pine, which is endemic to the central and southern Appalachians, and it's got cones that are serotinous. They only open when they're heated. that tells us something, you know, that tells us that fire has been on this landscape for a long time. We also have relic populations. Oh, we also have relic populations of many species, probably a lot of the same species that Mary has in the landscapes where she's working. We found a bunch of rattlesnake master the other day. We've got blue stem grasses and coneflowers and things, usually relegated to little strips alongside roads, right? But that tells us that this landscape was historically probably a lot sunnier and a lot more open. And then, so fire, you know, obviously has historically played a role here. And then through things, evidence like fire scars on trees, we can see that not all of those historic fires happened during the growing season. They could happen almost any time of the year. And I'll also add that, you know, after many decades of fire exclusion, you know, we see what happens when we take fire out of the equation, right? These diverse, heterogeneous landscapes just sort of homogenize in this process that we now call mesification.
All right. We are working on getting Todd's video on. But I think there was a follow-up question. I don't know if Matt or if Tyler want to jump in. Let's see. Yeah, I don't know if Matt or Tyler want to jump in. One of the other questions that kind of came in was, what positive impacts on plant species and or communities have you experienced by incorporating a phenological approach to burning? Tyler, I know at the Albany Pine Bush, you manage a lot with ecological goals in mind, as well as hazardous fuels reduction. Can you describe some of the, some of the effects of the burning, since you have been there, or, even prior to your joining the management team?
Sure. So I mentioned in the intro that the federally endangered species that lives here is the Karner blue butterfly, and it needs wild blue lupin to be prevalent on the landscape. So by burning, the lupin benefits from the disturbance of the fire. It needs ample sunlight to be found in the preserve. So when you top kill woody trees and shrubs, let the sunlight hit the forest floor once more, and the lupin will be on the landscape until it starts to get shaded out. So a positive of burning is you're keeping the forest open so lupin can be there.
Awesome, thank you for that. Matthew, we haven't heard from you quite yet. Do you want to chime in with your thoughts?
Yeah, I think that there can be a lot of potential benefits of burning more year round. I think when you limit burning to the quote unquote traditional months of, like, in our region, like kind of late winter, early spring, very early spring, you're not able to really affect as much change. And so I think I think of it a lot in terms of fire behavior. Oh. Yeah, I think of it in terms of fire behavior and how you can leverage that to achieve goals. And so, yeah, there's, I think, just a lot more, with oak regeneration being so difficult, finding ways to, focus on, understory species and yeah, just promoting kind of more of a, holistic effects on vegetation rather than the traditional, target species.
Awesome. Thank you for that. Todd is with us. His Zoom audio is kind of working, so I'm still here, but I'm gonna pass it off to Todd. Thank you all for rolling with us today.
Yeah, thanks. It's been interesting to try to get this ball rolling, but yeah, thanks for everyone, stepping up and whatnot to kind of take the lead, especially Amanda with the questions and whatnot. So yeah, I think that's a good segue into our second topic, that being, impacts to wildlife. And I know some of you have spoke about that, a little bit thus far, but it's a lot of our participants are certainly interested in the impacts to wildlife. And so really kind of a similar question. What are, what do the animals themselves tell you about, why, when, how to burn, and then again, kind of positive impacts. And again, these things blend just like ecology, right? Plants and animals aren't exactly separate. We artificially keep them a little separate in this conversation. But yeah, I would go, I would see what, you have to say about that. Don, Mary, Tyler, any of you can start the conversation on this topic, if you don't mind.
Yeah, I can start. I should preface this by saying I'm not a wildlife biologist, but I have had graduate students in my lab that have expertise in that area. And I think we can learn a lot by looking at what happens. We can learn a lot from the animals by looking at what they do when we don't burn. And in our region, in the Southern Appalachians, I think we're right there at the fringe of where you would historically find prairie warblers, for example. And prairie warblers are basically gone from our region because the habitat that they need, sort of that open, early successional sort of habitat that they need, doesn't exist. And you create that kind of habitat with fire. A lot of animals also benefit from just the heterogeneity that occurs at the landscape scale. When you're burning, you've got older forest over here, you've got younger forest over here, early successional habitat over here, different species in different places. Diverse habitat is going to favor a diverse assemblage of wildlife species of all types. So and Todd, were you asking me to talk about some results from some studies there, or just more general at this stage?
Yeah, some results would be good too, briefly touching on that. I do like what you say about, in a sense, diversity begets diversity, pyrodiversity begets diversity. And so that's kind of a big picture of this discussion, is how can we diversify our burn approach and open up the burn window appropriately for that diversity you're talking about. But yeah, some information, specific information would be good.
Sure. Well, and again, I'm working with land managers, some really ambitious land managers that are trying to expand their burning programs because they manage lots of acreage that hasn't been burned in many cases for a long time. And the only way they're going to be able to effectively do that is by taking advantage of every possible burn day, burning in seasons where they maybe traditionally haven't. And so we did some work not too long ago where we looked at bird communities. There's a lot of concern, especially with early growing season burns, about burning. When maybe ground nesting birds are there. And a graduate student of mine, Allison Melcher, did some work and found that we didn't study the immediate impacts. And certainly, like if you're burning, during the nesting season of a bird, you're probably impacting, individual animals or individual populations. But what we found, 1 and 2 growing seasons later, is that we saw way more birds after growing season burns, early growing season burns. We saw a greater diversity of birds. So there's more total birds. There's also more types of birds. And those increases in diversity were largely driven by increases in ground nesting birds and cavity nesting birds, right? So burning during the season when the ground nesting birds are nesting might actually benefit those same birds, in the long term. Looking at the habitat, those early growing season burns, we found, and Matt will probably talk about some of the fire behavior stuff. We found that they behave more variably across the landscape. And then that resulted in a more variable response in the plant community. We saw more openings in the canopy when we burned in the early growing season. Those openings were a little bit larger. We saw a little bit more early successional and sort of open forest habitat, more edge habitat, all the things that lots of different wildlife species are looking for in a habitat, that heterogeneity on the landscape. We saw that developing within a couple growing seasons after early growing season burns.
Yeah, it's interesting to think about the negative impacts. Obviously, the death of the organisms that we're trying to maintain or increase their population is obviously a negative when you're adding fire on the landscape. And part of the debate sometimes is, whether you're taking a species approach or a habitat ecosystem approach. And it's debatable at some point which one, which approach is better, depending on how you define that. At some level, if we're overly concerned with individuals, we might suppress burning to the point where that habitat degrades to the point where it doesn't support the species as anyway. And so it's sort of it's a slow death, if you will, to the population, as opposed to hopefully if it happens, a quick death to individuals, and few and far between, hopefully, on the landscape. So yeah, Matt, if you had some insight on behavior and that sort of thing.
Yeah, well, I think the topic was on wildlife, which I'm also by no means an expert. But yes, in regards to behavior, yeah, I think that's really where it all starts, is understanding fuel consumption, or what your starting fuel conditions are, and then what the weather is and how the fire behaves. And I think that understanding that is so foundational. But yeah, so just from a few highlights from the research that I was a part of in the Southern Appalachians. Yeah, we did see basically what you would expect. When you burn on hotter and drier days, you're able to cover more of the burn unit. So that was fairly consistent. So managers often like to report number of acres burned, but that usually doesn't encompass how much of the unit was even blackened. So we found that just by pushing the date forward, you can actually consume more. Yeah, and I think that could have lots of effects on wildlife. I mean, of course, you want to build that mosaic heterogeneity, those buzzwords, and get those that, because I remember that I had a colleague at Clemson who in wildlife who did on her master's thesis defense. She was concerned about how effects of fire may not allow enough coarse woody debris for her species of interest. And so that was kind of a good reminder of it doesn't all have to be super early successional. It can create that mosaic, and you can have some areas maybe that don't burn, and that's fine. So just but yeah, if first we had a first entry burn, and that in the end of January, that it was really difficult because so little of the unit was consumed. So but there is really good reason to do a first entry burn for other reasons, but ecologically you're limited when when you're not even consuming a lot. So
Along those lines, are there ways that you've mitigated these negative effects of maybe burning during a season when certain species are vulnerable, or any of the panel for that matter? But
I'll chime in there, Todd. So just listening to Don and Matt talk there made me think about some things. So when we're burning in our habitat, we only burn a third of an area at a time. So we always leave 2/3 as refuge to repopulate the area. And we do that especially for the Carner blue butterflies, because we don't want to burn them completely off the landscape, because no life stage of the Carner survives the actual fire, but they only exist in areas that burn frequently with lupin. And when I was listening to Don talk, well, some of the things I think about is what the unit looks like after it's been burned. So the prairie grasses like blue stem, Indian grass, little blue, they'll grow back, and it'll be a different shade of green. It grows back more vibrant. I know from burning at the there's a plant material center in Corning, New York, where I've helped the USDA burn there, and they burn to increase the seed yield for those prairie grasses. The lupin will grow back, it'll flower, so you'll have native species like New Jersey tea and horseman and butterfly milkweed. That'll grow back, and it will be available for plants and animals later in the season. And you'll also notice that like scrub oak will hold its color longer in the leaves, so it'll stay green later in the season. So like if you can see from this picture, if you had like a unit that didn't burn, one that did, at the end of the year when things are going dormant in like October, the scrub oak over here will have already turned brown, and then the scrub oak over on this side will stay green later, trying to get as much energy from sunlight as possible. So, but anyway, back to what you said, Todd, like, so we use the 1/3 rule to try and not kill everything in the area, because we do get mortality of, you know, some of the species that we like, but we're managing it, not for individuals, but for the ecosystem as a whole.
Right, and I think taking that mosaic approach, you know, not only protects some of the animals, the wildlife that rely on these areas, but as you indicated, it also provides a mosaic for the landscape. So because fire's changing the, you know, the soil environment, and my experience of with burning is, you know, an area might be kind of under the radar in terms of its diversity, or even at a cultural aesthetic value, you know, frankly, kind of boring in some ways. And you add fire to it, and it just explodes with flowering and fruiting. And so if we scale that up kind of trophic levels, well, now you're supplying food for other organisms and pollinators and seed eaters, et cetera, et cetera. So, you know, again, kind of that diversity begets diversity idea. It makes sense to divvy up a landscape, you know, so you're creating that mosaic and not, you know, overly harming any other of the wildlife species that can hopefully move out of there and go to some refuge. Anything from Mary or other panelists on this question?
Yeah, I can chime in. So where I'm a land manager is kind of also a biological field station. And so there is a heavy focus on monitoring a lot of our more threatened or rare species. And so some of those are like Massasauga rattlesnake and eastern box turtle. And so I know I've seen from my experience following a growing season burn adjacent to some of those prairie fens that the Massasauga live in, they will come up and bask in that short area in that first springtime when it's open. So they seem to have been benefiting and using some of those areas more in the springtime. I also kind of have an awesome view from my office. So I'll see often sandhill cranes like in the spring following a late summer burn. They have a lot more access through the prairies, and so they're able to walk with their colts through there more easily. Same thing with turkeys. I see them kind of moving through the area a bit easier and pecking at different insects that are on the plants or on the ground. But of course, we kind of mentioned some of those challenges with burning and kind of mitigating some of those things. With the eastern box turtle, we have had a lot of discussions with some of the researchers kind of surrounding their habitat. And we actually have a head starting program where we're collecting some of these eggs with proper permitting and incubating and hatching them and raising them all winter long, and then releasing them and monitoring them through several years. And so some of these head starts are very small. They're smaller than a baseball. And so when they're moving throughout the year, they're not very fast. And so growing season burns have kind of posed a difficult question about maintaining their habitat, maintaining an open area and a lot of herbaceous resources for them, while also making sure that we don't burn them up in the fire. And fortunately for us, a lot of those turtles have trackers on them. So we have the ability to identify their locations. We can do surveys through the area before a burn. We can be as thorough as we need to be, but there is always that risk. So we have looked at kind of mitigating that by burning in the winter or seasons when they're not as active. But yeah, with these species that live in fire dependent ecosystems, it's always going to be a difficult question to ask.
Right, and I think this is a good segue into the next topic, because you're talking about head starting turtles, right? You're literally handling these turtles and whatnot, and so intimately involved in the landscape, right? A part of nature, if you will. And along those lines, you know, moving on to kind of the social aspect of things, the professional or the cultural considerations. I guess the question, maybe I'll start with Mary. You know, some of those professional or social obstacles, cultural considerations that you have experienced or in your work in this fire world.
Yeah, I think there is a lot of fear about fire, especially working with some private landowners or even like local fire departments that are skeptical about our ability to use fire safely. I think growing season burns definitely provides an opportunity to slow fire down and make it a little bit more controlled. Of course, it's very smoky, and smoke also comes with its challenges. But it kind of gives the public a different perception of fire versus the spring, when fire can be very volatile. You can get some pretty insane flame lengths. This was a growing season fire, actually presented a good opportunity for us to do some learn and burn public educational events that we could kind of show fire in a very controlled manner with very slow rate of spread to a live audience.
Yeah, that's an interesting point, because if we restrict ourselves to the dormant season, you know, you're not only obviously restricting the burn window for ecological reasons, but you're really restricting the burn window for social and educational and training purposes as well. So yeah, yet another reason to expand the burn window. What about other folks, Matt, perhaps? What kind of obstacles have you run in professionally, culturally, socially?
Yeah, I often hear from, especially from state agencies, that you can't burn after about April 15th in our region because of just concerns of smoke impacting turkey hunting and then or effects on timber, as if there's a strong timber market, which I haven't seen in my lifetime. So yeah, it's just kind of these I think ways that things have been done in the past, and it's not necessarily bad. It's just like, how do we convince that, you know, we gotta expand the burn windows. So yeah, I'm it's part of it too is like, if you like, maybe you start off with something in the winter to, you know, as a proof of concept, and then you build towards burning later in the year. But sometimes it's just like being able to take advantage of an opportunity that you have that you know may not align with how it's been done before, but you just have to take advantage of it. So I think there's also a lot of there's kind of a tradition, or not, I don't know what the right word is, but of people moving out west for the Western North America wildfire season. And so that kind of leaves the lines. I mean, unless you have a fire manager who's like really, and there are those who do that, who prep over the summer. There's oftentimes kind of a languishing effect. Like there's just not the prep getting done over the summer. So then, you know, come fall, when you have some, you know, good burn days, that you're not ready for it. So those are a few challenges.
So kind of related to that, in terms of the social cultural pressures to open the burn window a little bit more, have any of you had experience with First Nations or tribal members in expanding using traditional knowledge as an avenue to expand the burn window, I guess?
Yeah, I can speak to that. So I'm a member of the Sault Ste. Marie tribe of Chippewa Indians, and of course I'm a pyromaniac. So historical indigenous fire has always been on the forefront of my mind. Unfortunately, because of a lot of the time and genocide, assimilation that occurred, we have lost a lot of that knowledge of what some of those historical fire regimes were and a lot of the details. But we do know some overarching concepts of when they would use fire and when these cultural fires took place. And of course, it's different for every tribal group. But a lot of times tribal groups would share knowledge, and so there are some parallel things across the US. But yeah, we know like berry production, a lot of times fire was used in the fall, following blueberry picking. We know that fire was used to stimulate forage for bison, and so they would, intentionally burn swaths to kind of control where bison were moving throughout the year so that they could have more opportune hunting. So yeah, we know a lot of those things, but we don't also know the specifics of like the fire, like what was the weather, what was the timing, how large, like on what scale. And then of course, today we have all these modern challenges of like climate change, new invasive species. A lot of our, specific plant community composition is a little different. And so it's like, how can we take this historical knowledge and blend it with our modern problems? And a lot of that is just through experimenting and doing what we're doing in the field, doing the research that we're doing, and kind of sharing our findings and our knowledge with each other.
Yeah, and I think it's really important that we're looking to people that have managed the landscape for thousands of years, right, for some insight on that. And yeah, we might be lacking some of that, the specific information, but I'm fairly confident that indigenous peoples did not just burn during the dormant season, right? They had different reasons for different seasons, kind of thing. Other folks that have worked with tribal members at all before we move on to the fourth topic, or anything else? So the fourth topic is really kind of the how-to, the implementation, and I know Matt in particular, and Tyler talked about this a little bit already, but not just so how do we operate in this world? What's some of the information and tools and resources that you use to kind of expand the burn window? And these can be technical tools, ecological tools, et cetera, et cetera. What allows you to expand the burn window and say, yeah, this is a good time to burn from a seasonal perspective? Maybe Matt or Tyler, perhaps, either or.
Okay. So I mentioned before the growing season burns that we're doing. Most of the ones that I've done here, those are done in tandem with a mechanical treatment where we mow the shrub layer, everything that's like 6-inch diameter and less down in the forest. And we do that between October and in December, and then we burn that the following year. So most of the burns that I have experience with, we've modified the fuel mechanically. And then for information or tools, resources to help you actually plan the burn, what you got to do is basically monitor the weather and the drying, because you're going to need more dry days to burn when everything's green than you do in the dormant season. So we're fortunate enough to have a weather station right outside of the center here that I look at constantly, but you can also deploy fuel sticks into the forest, 10-hour fuel sticks, and check that daily to track the drying. So you want to check the weather. You want to monitor how dry the fuels are with a protimeter or measuring a 10-hour fuel stick, and then track the Keach-Bryan drought index, which will tell you how dry and available the duff layer is, the decaying organic material, because that can contribute to fire behavior, can also contribute to smoldering, which can be a concern. So those are some of the I guess, the tools that we use to help plan.
Yeah, and you bring up a good point about, you know, we think about this from one direction in terms of applying fire to change a plant community and eventually a animal community. But the reality is those communities, depending on when you burn, also affect the fire behavior, things like smoke, rate of spread, et cetera, et cetera. So that's kind of the other side of this discussion as well, from more of a fire science, fire behavior standpoint. So yeah, I don't know if Matt had anything to say additionally on this topic, or anyone else for that matter on the panel, of course.
Yeah, sure. So, well, I'm a long way from becoming a burn boss and may never become one. But in my role, I want to help support managers, and so I can think of countless tools to help with decision making. And there's, you know, it's ever changing. Like just so much. There's so many tools to keep up with, bookmarks and articles and websites and equipment and you know, technology transfer. There's so many things happening that, you know, there's a wealth of information and good tools out there. But yeah, in my role, I'm hoping to take more or lead take more initiative, or not initiative, I don't know, I'm trying to help support managers through adaptive management more with better reporting. So we have a lot of good data collected in the Southern Blue Ridge on fire effects, but we haven't. We've been collecting data for so long, and yet it's hard. It's not always easy for managers to access, and so that's I hope there is that, you know, by being able to better analyze and see trends over time, we can, you know, start pulling apart like how burning, you know, in different, however you divide it out by month, by some, you know, defined season of interest, by, you know, under certain weather variables, you know, be able to really start understanding that. But we're just not there yet to really be able to, like, you know, easily query that data and you know, share it all together. But that's something that I'm really excited about and hoping to do more of.
Yeah, and you know, it's certainly, there's a wealth of information out there, of course, and sometimes splitting out the stuff that has, you know, get more bang for your buck, so to speak. But you know, we're talking about ecology and fire ecology and nature, and trying to distill that down to a couple things can be quite difficult. And one of the things, you know, that in the idea of phenology is paying attention to, again, the plants and the animals, what they're doing at a particular time of year as a tool or a resource, so to speak. So, you know, really observing the environment that you're attempting to manage, I think in a lot of ways is a tool or a resource in and of itself. And so yeah, I mean, we have technological advancements, thermocouples, we can measure rate of spread and temperatures and those kinds of things. But you know, perhaps sometimes it takes the 30,000 foot view in combination with that to say, okay, when I apply fire, it's a good time to apply fire. These particular plants and animals will benefit. These other plants and animals perhaps won't benefit, and maybe we want that, right? But yeah, it's a challenging world, but also you know, the world's sort of our oyster when it comes to fire ecology, science, and management. Yeah, so and that kind of gets at our last official topic, and that's the what's next. What are some of the you know, what do we want to learn moving forward, both from a qualitative standpoint or quantitative, right, from a research perspective? What are some of the things that would help the fire community, you folks in particular, right? If you had you know, we just got done with the holidays, but if you had your wish list, right, moving forward, what kind of things would you like to know in a you know, moving forward? I'll kind of open that up to y'all.
I can jump in there. I know for myself, I've been doing a lot of literature review on fire seasonality and biodiversity, and there is a lot of resources from the plains, from Western areas. There's a lot of information from Australia, but there is a really big gap in knowledge for our Midwest, Northeast systems. And so while a lot of those resources are still somewhat helpful, we have a lot of really different climates, a lot of really different plant species. And so I would love to see more research being done, which of course, that's what my project is all about. But I think it'll be very helpful to land managers in these areas that are working with all these different species to kind of have more reliable results or predictive results of saying, you know, like, this is what big blue stem does when it's exposed to fire at this time of year, or this is what forbs species or legumes are doing at this time of year. Of course, there's always variability within individual species of a certain functional group, but it would be nice to have some sidebars as to like what we can expect in our region.
So more regionally specific information, that makes sense, right? You know, burning is local, right? So having that local information makes a lot of sense. Yeah, so Don, I see that you want to chime in here.
Sure. Yeah. I mentioned at the beginning, coming from Florida and then coming up here, and how, in many ways, the study and practice of prescribed fire in this region is just not as, I guess, kind of like what Mary was saying. It's not as well developed as it is elsewhere, and so there's this lack of long-term studies. Everything that Matt and I, the research that Matt and I have been referencing, was all, studies of a single burn, usually a first entry burn with data collected, before, during, and then right after, right? And then we studied birds 1 or 2 growing seasons after that, right? But so we know a little bit about what a single early growing season burn does, but what we don't know is, okay, well, what about just incorporating growing season burns into a fire regime, and what does that look like over longer periods of time? So I'm hopeful that in my career, that's something, we make that next step. We're just not there yet. And another thing, and this kind of echoes a lot what Mary said, there's a lot that we just don't know about these plants, like, in the coastal plain, they've got wiregrass, and we know that the flowering and seed production in wiregrass is influenced by fire seasonality. And so we can look at the phenology of that plant and infer a lot about, how we should be burning. I don't really know we got a lot of species here. We got like 2,500 species of flowering plants here in the Southern Appalachians. There's probably a species that tells us that's got a story to tell like that. To my knowledge, we just don't know what it is yet. I think for too long, in the Southern Appalachians, plants have, in the fire, in a lot of the fire research, the plants have just been looked at as fuels, right? You got your live fuels and you got your dead fuels. And I'd like to see us move beyond that and pay more attention to these plants and see what they can tell us.
Yeah, you touch on a couple interesting things. One is the long-term aspect of things, right? Naturally, areas didn't burn once, right? They burned, multiple times. Now, one of the gaps that, or things that I work on actually in my research, Mary and I work on, is not only seasonality but this idea of order, right? So perhaps an area burned. Well, in our research, we're testing this idea of burning an area in spring in one year, and then 2 years later burning it in fall, and then 2 years later burning it in spring, and this in kind of trying to replicate nature, if you will, to say, okay, what do we get from that? Does that matter? Does the first burn from a suppressed ecosystem that hasn't been burned in 20 years or 10, 20 years, does that set a certain trajectory if you started in spring versus if you started in fall or what have you? And Don, you mentioned the wiregrass. I did a postdoc at Savannah River site, and that was when I was talking about when fires applied, things just blew up in terms of flowering, and that was what the plant that I had in mind actually. And after a burn, the wiregrass just it was just waiting to be burned, basically. And I also think it touches on this other idea of really natural history, right? It's somehow difficult to be a full-on ecologist knowing everything about everything, right? We tend to specialize and narrow, but as you say, really looking at the plant, the individual plants, right? And I would say when we talk about phenology in a larger sense, we talk about the dormant season, and folks perhaps gathered this from the very brief PowerPoint there, that we talk about the dormant season and the growing season, and moving forward, it depends on which organism you're talking about, plant or animal, right? So yeah, when we're talking about plants, by and large, in the dead of January, sure, most everything's fairly dormant except for conifers, right? To some limited extent. So really kind of, in my opinion, a knowledge gap, and something that I want to look at is, keystone species, indicator species that we can really focus on, right? In that generic PowerPoint, what have you, leaf out. Well, we know trees leaf out at different times of the year, different periods of spring, so to speak, spring. And so some of our terms are very ambiguous, right? I mean, what is spring? Is it that start on March 21st? Well, depends on the organism you're working with. And one of the things that I'm personally looking to do in research is tie these things in a little closer to things like growing degree days. I think growing degree days is maybe a stronger way, and that's related, not just as in a general sense, but you can also tie that into specific species. Because, say, for instance, you want to do some burning to reduce autumn olive. Well, the phenology, the leaf out, the spring versus the dormant for that population of autumn olive is going to be different from year to year, right? I mean, we have a particularly warm spring. Well, things are going to pop much sooner than if we have a relatively cold spring. And knowing that information and tying that with our fire management to, again, help the species that we want to help, and decrease the population of the things that we want to control more in terms of non-native invasive species and that sort of thing. So yeah, what are some other gaps or information that you would like moving forward?
I just want to echo for a minute what you said about growing degree days. I love that idea. One of the big species, just to give another example, one of the big species we're trying to control here is red maple. And red maple is a major competitor, for a lot of our oak regeneration. And its growing season, if you will, starts really, really early because it flowers in the wintertime, basically. It gets it accumulates a couple of growing degree days and it flowers. And then it is dropping those seeds, when it's technically still the dormant season for a lot of other species. And so I've oftentimes wondered, and we see this to an extent in the data and also just anecdotally, in our region, if we're burning in the dormant season, are we just preparing the seed bed for the millions and millions of red maple seeds that are about to fall? Mm-hmm. Whereas if we push it into the early growing season, mm-hmm. Paying attention, because red maple is going to flower at different times depending on growing degree days, but kind of pushing it back a little bit into the early growing season, you might burn up all those red maple seeds that just fell, and that's going to further facilitate, your oak regeneration.
Yeah,
so I really like what you said about growing degree days.
Yeah, that's an interesting approach too, to think about kind of a layered approach to burning, where you burn in a season to actually encourage the thing that encourage the seedlings or the seed bank of the things that you want to decrease, right? So you burn, allow those things to, it's kind of like I work in restoration, so it's kind of like tilling up an ag field, right? Encouraging the weeds to actually grow so you can burn them, herbicide them, till them under again. But yeah, thinking about this as a kind of successive burns in a sense, and of course incorporating phenology in that approach, right? And then this relates to also the operational aspect. Maybe the best time to burn for some species is when you can't burn. In other words, there might be 6 inches of snow on the ground, right? I mean, those are the times that you literally can't burn, even though it might be the best time to knock a particular species back. And that might be where we have to, again, think about individuals and say, well, we're going to have to shift our burn window, and that's not going to meet the objective for a particular species, but as the whole, it will improve the whole. So maybe you get more red maple in some areas, but you also have less of something else in another area on that particular property. So other last minute wish list items, knowledge gaps that anyone like to put forth?
I think one I just kind of have to mention is like no growing season burn is even the same. Like depending on fuel loading and weather conditions, and firing operations, you're still gonna get a lot of different fire behavior, and different fire intensity and severity. So it's really hard to collect all of that data and the plant data and actually make it interpretable. But that would be my wish list, is just to kind of know more about those different parameters and how it affects the plant community response.
Yeah, it's kind of distilling, it's kind of taking fire science, fire ecology in a general sense, and trying to distill it down to not one or two things. I mean, that might be nice, but I don't think there's a magic bullet per se, because we're dealing with, communities and ecosystems. But that said, some approaches have more positive impacts on the community as a whole than negative. And I think, if we're looking at a habitat approach or ecosystem approach to management, that's kind of the triage we have to make oftentimes, right? All right. Looks like we're 12:12 here. So for the last, we're going to, I think, have some time for some questions from the participants. And if I remember correctly, I think Amanda is going to take the lead on that. Is that correct?
So actually, Jack's been tracking that, and a lot of the
good.
questions that participants have submitted have been covered more or less by the panelists already. So I think you're welcome to keep going, or you can send it around for kind of concluding thoughts. Either way.
Yeah. So I guess for the panelists, I know we took this sort of linear approach, bounced around a little bit, but I guess I would ask the panelists. Things that popped up in this discussion that are interesting, surprising, new to you, that kind of get the ideas flowing. How does our discussion maybe impact your research or operations moving forward, right? Or any, again, following up on any of our topics if you feel you didn't have the chance to really expound upon them.
Yeah, I think kind of jumping off of what Mary was saying, I think there's just a lot more like foundational knowledge needed around tying burn season to specific variables. I think we all hear about, relative humidity and, days since rain, all these different number metrics, but actually like having more of a shared conceptual framework. I think there's a lot of work to be done in that space. And so I think that would be helpful. So, making sure that we're using, because especially as, we have like, whether it be like an El Nino, like we're in now, or, just like as climate gets more variable, like, the traditional seasons are going to be less meaningful. So I think, getting all on the same page about all the variables. And I know there's a lot of variables. I know there's a lot of metrics, and some are more important than others. But if there's ways that we can use the same language, I think that would go. Just communicating well is the starting point.
Yeah. Other thoughts? Expanded thoughts?
Yeah, I think Matthew really hit the nail on the head there. From like a researcher standpoint, just being able to talk the same language within academia. If there was a way to kind of work together with these different regions and, clue in on like, what are we going to use? Is it growing degree days? Is it like temperature of fire? Is it flame length? Is it so many different metrics? If we can decide on universal ones and then compare those, that would be really helpful for, you know, understanding some of our similar results or similar trends that we're seeing. Because, you know, we have Kentucky bluegrass. I'm sure you guys have Kentucky bluegrass. We might have some of the same offenders in some of our systems. And, you know, if some things are working for you, we can kind of clue in on, you know, what are the circumstances that it's being suppressed or it's being increased. Yeah, that's what I got.
Yeah, so there's some space for you know, some species specific work for sure. And perhaps, you know, depending on your approach, you know, we start with the most harmful invasive species, and studying that particular species, the phenology of it, and then also the fire science and ecology and application to see, okay, what's the best either season or how many growing degree days is kind of the best window to apply fire to knock this species back. And then, you know, perhaps when that species is knocked back, so to speak, then you can move on to the next most important species, whether they increase or decrease, really. And if you're lucky enough to have a relatively intact, you know, invasive species free area, well, then you can focus on the good, right? You can focus on those species that provide for other wildlife species or rare species and that sort of thing. So there's a lot of space, as I had mentioned before.
Can you
yeah.
I love, again, I love this idea of, you know, thinking about growing degree days when thinking about seasonality. I think it'd be cool if you looked at your fire weather and it told you like how many growing degree days for that particular day. And maybe they do, I don't know, in some places.
Well, so what I do in my research, and it's a long-term research project. It's been going on for a few years now. So it's Mary's project. So she'll be popping the top off this thing, you know, relatively soon. But with that, I use biological zero as my, you know, as my point of growing degree days, so to speak. And you can calculate this easily, right? Every place has a local airport that takes temperature data every day. And so you can calculate, or what I do is I calculate, okay, that March 13th burn or whatever was 422 growing degree days. And that, you know, that August 15th burn was 1,250 or whatever the deal is. And so in terms of that knowledge gap, so what I would ask practitioners to do, you know, we know the dates that we burn, and we can figure out how many growing days that is with local weather. And more importantly is looking at the fire effects, right? So, and that's how we can do that on our own properties, right? So one year we burn at 300 growing degree days, another year it's 500, another year is 1,000. But really paying attention and monitoring to those fire effects. Again, if I'm trying to control autumn olive, I want to be able to see, okay, at 300 growing degree days versus 500, about the same effects. But when I burned with 800 growing degree days, that really knocked back the autumn olive. And I think that approach, at least I think it's a little qualitative. Well, it doesn't have to be qualitative, but I think it gets to that idea of really zeroing in on both some data that's quite easy to get, but then more importantly is relating that to fire effects, because that's kind of ultimately what we're trying to do here. We're trying to look at fire effects on species and communities and that kind of thing. So yeah, I would say that it can work if we get good monitoring of fire effects on species.
And could you just in case there's people in the audience that are unfamiliar with growing degree days and then the growing degree day calculation, can you just like in layman's terms talk about what goes into that?
So the basic idea is at 5 degrees Celsius, microorganisms, like the biological world doesn't really move along. And so in the sense, you know, in Michigan now when it's, you know, quite cold out, you know, not a lot of things are moving, things aren't growing per se. And then spring, you know, you get a few of those days in spring, and that really starts the soil community doing its thing, and the plant roots starting to do their thing. And so things start growing, so to speak. And so we can calculate how many days, and there's a more complicated formula to it. It's not particularly complicated, but we can figure out how many basically it's a function of how many warm days. If I'm really breaking it down, how many warm days occurred where the biological world, plants, organisms are growing, up to a point. So like I said, from January 1st to January 30th, there's probably in our area 0 degree, there's no growing degree days. In February, you might get one warm day in February. Well, then we can say, okay, we had one growing degree day, so to speak. And when we talk about phenology, in relation to weather and climate, the idea of maple syrup, for instance, well, that has something to do with growing degree days, right? We want warm days and cold nights, and late February, the sap starts running. Well, the time that sap starts running in sugar maples, for instance, it depends on how warm the days have been, how many growing degree days, right? And so I'm not a maple sugar bush person or anything, but that would be a way that you could decide when to start tapping trees, saying, hey, we've had 40 growing degree days, 40 warm days, the sap should start flowing, let's tap into these trees, et cetera, et cetera. So in a nutshell, it's how many relatively warm days have occurred that kind of triggers the growth of things, phenology and that sort of thing.
And just to add to everything Todd just said, it is widely used in agronomy. And so there's a lot of resources that have been developed.
Yep.
But then even also in like ranching and pasturing, there's a lot of markers for like certain grass species that hit a certain phenology point or flowering at a certain range of growing degree days. So it's a bit more calculated than just saying, big blue stem flowered at this day on this year. You can actually cue in on a very range.
And yeah, you bring up a good point, Mary, because it's really out of agriculture. Like if you search Google for growing degree day calculators, there'll be a bunch of them. They'll be centered on, hey, when should we plant soybeans? When should we plant corn? And corn as a warm season crop, you can change the parameters. I use biological 0, but you could use 40 degrees Fahrenheit if you want. So it's plant specific. And so, but yeah, it's drawn out of agriculture, right? All right, I think we're just about to wrap up. I think I'll turn things over to Amanda.
I actually have kind of a final question that's been, so climate change has been mentioned today, and I don't know if in just the last few minutes, if our panelists can talk a little bit about some of the effects of climate change that you have seen impacting the phenology of the systems that you manage, and that feeds into maybe what you want to have, what knowledge you would like to have, but it might be useful for our audience to hear a little bit about those impacts as well, if you have a moment.
I can jump in on that very briefly. So I know like in our region, this past year, we had a really long drought right in the spring. And so a lot of the flowers weren't flowering, weren't blooming, or if they were, it was like maybe a third of what it traditionally was. And so that definitely made me reconsider some of the growing season burns that I had planned, because I didn't want to put additional stress on that plant community. I think we did end up doing some burns, but they were much later. They were more like September, October. But yeah, climate change is definitely a real driver of changing our regional weather patterns. So it definitely shakes things up year to year.
Yeah, in a nutshell, it's going to move things, with warmer temperatures, that's going to trigger things to, move faster. So, the sugar maples are going to start running, earlier than they traditionally have, right?
Yeah, in our neck of the woods, what we've really seen is a lot of climate volatility. We'll have a really dry, a record dry year followed by a record wet year. I mean, in the 12 or so years I've been at Clemson, I think we've had, I don't know, a couple of 500-year rain events and a couple of really serious droughts. And one thing that I have noticed, and I haven't really thought about it so much in the fire context, but I also do the fall color reports for the Southern Appalachians. And there's a tendency sometimes to think that like the year just resets on January 1st. Whatever happened last year, well, that was last year. Well, one thing that really comes to mind was 2016. We had a very severe drought. We also had some fires that year. But the effects of that, 2017 was more normal. But the effects of that carried over into 2017. Trees went into the dormant season under stress, and that influenced their phenology in the following year to the point where we had an early leaf drop in 2017 that I attribute to the drought of 2016.
Yeah,
Yeah, there's carryover here.
Yeah, bouncing off that, regards to leaf drop, here in Western North Carolina, this past fall, we had a hard frost on Halloween, and then it seemed like it got really high dry system set in, and so there was elevated fire risk or start potential or related to that, and so that seemed to be maybe an effect of, or maybe it's just a heightened effect, or it just seemed to be really pronounced going into November. Just had a really relatively high fire danger, if you will, period, that I'm wondering how that was influenced by climate.
Yeah, and operationally, right? I mean, we have these ideas of saying, oh yeah, we want to burn during this particular time, right? But of course, then nature happens. Climate change drives some of these things where it's like, yeah, there's a month there where it's going to rain every day, and you're not going to be able to burn, and kind of rolling with those punches is part of the. I mean, in the absence of climate change, I guess, this anthropogenic climate change that happens, and I think climate change exacerbates that reality. So.
Yeah, thank you. And Tyler, I know with the Albany Pine Bush, you've been re-examining your weather and fuels parameters. Can you touch on that briefly?
Yeah, we recently did some research, and we were looking to expand our opportunities. So we reached out to people that burn in New York and then surrounding states to see what kind of weather parameters they were using in their prescriptions, and we ended up slightly modifying ours to be able to burn under slightly lower relative humidities and fuel moistures, and also higher Keach-Byram drought index. And as we were talking earlier about burning in the growing season, a lot of times, unless we've modified the fuel, the vegetation burning on naturally wouldn't be able to occur, because we would be out of prescription, because we'd be in some sort of drought or elevated fire danger risk during the summer.
Thank you. We're just a minute before our half hour, and so please allow me to thank all of you. Thank you, Todd, Mary, Don, Matthew, Tyler. Thanks also to Jack and Eric and the team behind the scenes. Thanks to our participants who also were blowing up the chat with some really, really rich discussion and resources, which we will try to post and share on the Fuel and Collaboration website, which has been dropped in the chat a few times. A recording of this panel will be on the Northern Research Station website, as well as the Fuel and Collab website. Catch us on February 15th for our final panel discussion of this season. Thanks everybody so much for being here. That's a wrap. Thank you.